Okay. So on Friday we talked about volume of a pyramid, and today is volume of cones, naturally, right? So volume. This is all very predictable because cones are just a special type of pyramid in which the base is a circle, right? So if we have a cone like this, right? We know that the volume is 1/3 base times height because that's the volume formula for a pyramid. But what is B in this case if it's a cone? I don't. I have white paper in there.
Yeah.
That's all I got. So what's B? What's capital B in this case? Pi r squared. So this is just going to be 1/3 pi r squared times h. That's it. That's the formula. Capital B, that's the area of the base. And in the case of a circle, it's pi r squared. So that's why that's pi r squared. 1/3 pi r squared h. That's the volume formula for a cone. Okay? So if we had a cone like, suppose it was a cone like this. And let's say this was 14 inches across, and the perpendicular height right here is 10 inches. Then the volume would be 1/3 pi times 7 squared times 10. So 7 squared is 49 times 10 is 490. So this would be 490 over 3. And that can be simplified out of pi. That would be the exact answer, which is Q. Okay? Pretty easy. One thing to notice is definitely Cavalieri's formula still applies. Still applies. What does Cavalieri's principle say? Do you remember me talking about it at all?
Yeah.
Okay.
If any two prisms also in the same bases, dual cross sections at any level they want to.
Yeah, okay. So it basically says that it doesn't have to be a right prism or a right cylinder or a right pyramid or a right cone. It could be like kind of slanted and it still works. Okay, so like for example, I could have a cone, instead of a right cone, it could be a cone that is sort of like off center like that. You have a cone that's shaped like that. This is a non-right cone. The base is still a circle, and each cross section is still a circle, but the vertex is not directly above the center of the circle, right? It's like off to the side. So if you have a cone that's shaped like this, and let's suppose its diameter was like 10 feet, and we knew the perpendicular height, this distance right here, that would be the perpendicularly measured height, right? Measure just to the ground, like next to this circular base. Suppose this distance was like 12 feet. The formula would still be the same. The volume would still be 1/3 pi r squared, which is 5 squared, times height, 12, perpendicular height. So this would simplify to be 1/3 of 12 is 4. 4 times 25 is 100. So this would be 100 pi cubic feet. Right? So if you think about composite solids that might involve cones, maybe it would be that silo problem that we talked about before. So the silo, instead of the way it was before, maybe the silo is a cylinder with a cone on top. Maybe that's the shape of your silo. Maybe that was the shape it was before, I don't remember. But last time we were talking about surface area, this time we're talking about volume. So they might ask you to calculate the volume of the silo now, including that top part. So if we had all these measurements, it's easy, right? Like if I had, suppose I knew that it was 8 feet across, and this cylindrical part is 14 feet tall. And let's suppose the cone part at the top was 5 feet tall. Then we have everything we need here, right? To find the volume, it's really just the volume of the cylindrical part plus the volume of the conical part. So the cylinder, what's the volume of the cylinder?
Pi r squared times height.
Yeah, pi r squared h. So this would be pi times 4 squared times 14. And the volume of a cone is 1/3 pi r squared h. So this would be 1/3 pi times 4 squared. Same radius as the cylinder, but different height. It's 5, right? So here I have 16 times 14. Let's use a calculator here. So 16 times 14 is 224. This is 224 pi. And this is 1/3, 16, 5. That's not going to go evenly, but 16 times 5 is 80 divided by 3. Yeah, see, it's a, so it's just 80 over 3. Now this is one that they probably wouldn't want you to leave in terms of pi, just because it's a little weird. So let's find a decimal answer for this one. You take 80 over 3. Let me start over. So I have 80 pi divided by 3 plus 224 pi. And if you're ever in doubt as to whether or not you need all these parentheses, I mean, you need parentheses at all, then use parentheses. But in this case, I think it's going to work out fine because you think about order of operations. It's going to do this multiplication first, then this division. That's good. Then it's going to do this multiplication. That's what we want. And then it's going to add those at the end. So just by order of operations, I think this is going to work out fine. So it's 787.5. Cubic feet. Corn stuff. Okay. 1/3 by R-squared H. Questions? All right, that's all I got for today. So the homework is Delta Math, and it's just called volume of cones. Oh, there's also an IXL assignment, volume of pyramids and cones. Okay. There's a what? A new homepage? Oh, nice.